If you've ever looked at your unit circle, you would have noticed that the space between 30 and 45 degrees is less than the space between 0 and 30 degrees. And the angle that's missing in order for all the spaces to be the same would be 15 degrees, and 15 degrees in radians is pi over 12. So another set of questions that we are now able to do without our calculator because of the sum and difference formulas are pi over 12 questions. So you will be able to figure out the exact value of cos of 15 degrees without your calculator, or sine of pi over 12 without your calculator. And the same thing goes with the angle between 60 and 90 degrees is 75. We're going to be able to figure out all of these pi over 12 questions now without our calculator. So on the exam you get, find the exact value of cos of pi over 12. Well, how do we do that? Because it's not on our unit circle. How can we use what we know to figure that out? And the solution that we're going to use is we're going to use our alpha plus beta formulas and the values that we already know from our unit circle. So we know pi over 3, pi over 4, and pi over 6. And now beside pi over 3, I wrote 4 pi over 12 because that's what pi over 3 is with the denominator of 12. And same thing with pi over 4 and pi over 6 being 3 pi over 12 and 2 pi over 12. And what we want to do is we want to either add or subtract these to get the pi over 12 family member that we want. So looking at cos of pi over 12, can you figure out a way to add or subtract those values that we have to get pi over 12? For example, could you see that if you took 4 pi over 12 minus 3 pi over 12, you would get pi over 12? Or maybe you chose to say, I'll take 3 pi over 12 and subtract 2 pi over 12, and that will give me pi over 12. Now, we don't only have to use the first quadrant answers. We're going to be able to use any family member, and we're going to see what that looks like in a bit. But to start off with, we can say, okay, let's say I want to use 4 pi over 12 and 3 pi over 12. Then cos of pi over 12 is equal to cos of 4 pi over 12 minus 3 pi over 12. And we say, well, how does that help us? Well, that helps us because if I simplify 4 pi over 12, it's pi over 3. And if I simplify 3 pi over 12, it's pi over 4. And now I have a cos alpha minus beta. And here we know alpha is pi over 3. We know beta is pi over 4. So we can use our sum and difference formula and again I can label these. This was my cos alpha cos beta plus sine alpha sine beta. And even though we write out 4 trig functions now with alpha beta, each of those is on our unit circle. So it becomes a pi plate question. I know what cos of pi over 3 is. Am I scrolling too fast? Yes. How far up? Should I go here and wait for a bit? So the next step is we have our values on our pi plate. We know that cos of pi over 3 is a half. Cos of pi over 4 is root 2 over 2. Sine of pi over 3 is root 3 over 2. And sine of pi over 4 is root 2 over 2. So we can plug all those values in, multiply our fractions together, we'll have a common denominator, and it will be all over 4. So we can say that now we know cos of pi over 12 is root 2 plus root 6 over 4. And we found an exact value for pi over 12, and the way that we found that was we used the values we already knew plus our sum and difference formulas. So part B said, can you find sine of 75 degrees? So for sine of 75 degrees, now we have to think, okay, are there two values on my pie plate that can add or subtract to 75 degrees? The most common answer that people think of is 45 plus 30. But you could have also done, say, 120 minus 45. That also makes 75 degrees. There's more than one possibility for each of these questions. But whichever one you think of first, that one will work. And if I convert 75 degrees to radians, and that's why I have the 5 pi over 12 up at the top, it's just to show you that it is a pi over 12 question. But you can get these pi over 12 questions in radians or degrees. They're just easier to recognize in radians because they'll always have a pi over 12 in them when they're radians. So once you've changed 75 to 45 plus 30, then 45 is your alpha, 30 degrees is your beta. So you can go to your formula and say my sine alpha plus beta formula is sine alpha cos beta plus cos alpha sine beta. All of those values are on our unit circle. Sine of 45 is root 2 over 2. Cos of 30 is root 3 over 2. Sine of 45 is root 2 over 2, and sine of 30 is 1/2. Again, multiply those fractions. And we get root 6 plus root 2 over 4 again, which happens to be the exact same answer as the one above it. This doesn't always happen, but with sine and cos, you will always have a root 6, you will always have a root 2, and you will always have it over 4. That's true for sine and cos. The thing that changes is sometimes the root 6 is negative, and sometimes the root 2 is negative, and sometimes both of them are negative. So that's what's going to change. Now we're going to do another question, another pi over 12 question. This time we're going to go beyond the first quadrant. So our next question is 17 pi over 12. And before we do this, I have a challenge. The challenge is we are going to figure out as many different ways to add two things from our pi plate to make 17 pi over 12. The rules are that you can use any pi over 4, any pi over 3, any pi over 6 family, any family member that you want, as long as it adds to 17 pi over 12. Okay? That's your job. You just have to find one. Once you find one, you call me over. I put it up on the board, and then that one is no longer available for anybody else in the class. So if you find it first before somebody else does, I put it up on the board, and then if that's the one you just find, and you're like, oh, now you have to find another one. Okay? So your job is to find two things from your pi plate that add to 17 pi over 12. No, 6 of them. We got 6 up there. We got 5. You guys came up with 5. I threw a crazy one up there, which you'll never use, but it does work. We have 6 of them up there. One of the things that we're going to look now, is there a pattern or something that we can use from the 6 examples that we have to help us find something quicker? Because you're going to be asked to do these pi over 12 questions, and you don't want to spend half an hour trying to find the 2 angles that work. So if we look at all of the ones that we have so far and try to highlight a common theme, what's in every single one of them? Pi over 4 shows up in every one of them, somewhere. Doesn't have to be first, or it's second, but there's a pi over 4 every single time. And the reason that is there, we had I had highlighted it in our notes before, but you probably didn't know why I had written that in red. But if you look at pi over 3 and pi over 6, when you change them to be pi over 12, they're both an even number times pi over 12. For example, pi over 3 is 4 pi over 12, pi over 6 is 2 pi over 12. But when you take pi over 4 and make it into a pi over 12 question, it's an odd number. And all of our pi over 12 questions that we're going to do are always going to be an odd number times pi over 12. If it's an even number times pi over 12, like if I gave you 16 pi over 12, it's no longer a pi over 12 question because you could reduce this, right? I could divide both by 2 and I get 8 pi over 6, and I could divide that by 2 again and find out, oh, that's really 4 pi over 3. That's not part of my pi over 12 question family. But if I have an odd number, the only way I can add two numbers together to get an odd number, one has to be odd, one has to be even. So if you were asked to do 21 pi over 12, what you're going to do is start with any pi over 4 family you want, and it doesn't matter which one. Okay, AJ, pick a pi over 4 family. 3 pi over 4. So if he wants to start with 3 pi over 4, well, 3 pi over 4 is 9 pi over 12. And if you wanted to get to 21, what would you have to add to that to get to 21? You'd have to add 12. Did I make a mistake here? What is... Oh, I did. Okay, we're going to start again. We're going to keep your 3 pi over 4. My problem with 21 pi over 12 is it's not part of the pi over 12 family. Why? I can divide both of these by 3. Let's pick 23 pi over 12. That doesn't simplify. So your pi over 12 will always be a fraction that doesn't simplify. And it will always be an odd number. I just happened to pick an odd number that was divisible by 3, and it did simplify. But if we started with his 9 pi over 12, and then said, I'm starting with 3 pi over 4, which is 9 pi over 12. What would I have to add to 9 to get to 23? I'd have to add 14. And whatever number you put second, when you reduce it, it'll always work out to be something on your unit circle. So the key to these questions is always starting with a pi over 4. So in our notes, I have that as well. We've got all those values. We could choose any one of them, and each of them will give us the same answer. But for the exact value of cos of 17 pi over 12, I happen to choose the 21 pi over 12 minus 4 pi over 12, which is 7 pi over 4 minus pi over 3. So sometimes we just choose a pi over 4 family that we feel is going to be close to 17 pi over 12. So I chose 7 pi over 4 because that's 21 pi over 12, and that's really close to 17. And then once we have our values, then our first values are alpha, our second values are beta. We can write out the formula, cos alpha, cos beta, plus sine alpha, sine beta. Think about your quadrants and figure them out. Now, cos of 7 pi over 4 is in quadrant 4, so it stays positive root 2 over 2. Cos of pi over 3 is in quadrant 1, it's going to be a half. Sine of 7 pi over 4 is in quadrant 4, and sine is negative in quadrant 4, so now that'll be negative root 2 over 2. And sine of pi over 3 is positive because it's in quadrant 1. Multiply those all out, they're all over 4, put your fractions together, and you will get root 2 minus root 6 over 4. So once again, we have a root 2, we have a root 6, and it's all over 4. This time the root 6 was negative. Sometimes these questions have a part B. Okay? And the part B says, Can you find secant of 17 pi over 12? Well, in part A, you just found cos of 17 pi over 12. So in part B, to find secant of 17 pi over 12, you take your answer that you got in part A and just do the reciprocal. And part B is usually only worth 1 mark. Now, lately on the exam, if they do a secant of 17 pi over 12 or a cosecant of 17 pi over 12, they give you part A to do sine or cos. And so part B is just flipping your answer. Because it used to be that this would be a 4-mark question all by itself. And if you didn't think about doing cos first and then flipping the answer, then you got 0 out of 4. And so too many students were not knowing how to start and getting 0 out of 4. So now they, to be nicer, they started the part A and added a part B to sort of give you a hint along the way. We'll do one more question. This was from an exam. And then the number 7 there is going to be the question for practice afterward. This is a pi over 12 question. Can you figure out cos of 11 pi over 12? Yes. There's a 4 out in front. That makes it look a little bit different. And because of that 4 out in front, it caused some people just to shut down completely. They left this question blank because they didn't like that 4. All that 4 means is 4 times cos of 11 pi over 12. So if we find cos of 11 pi over 12 out first, all we'll need to do is take that answer and multiply it by 4, and then we'll figure out what 4 cos of 11 pi over 12 is. So again, cos of 11 pi over 12, let's figure that out first. We start by writing cos. What are 2 things that add up to 11 pi over 12? Well, pick a pi over 4 family member. 11's not that big of a number. Maybe you just want to choose pi over 4. Right? I'll write it off to the side here. You know that pi over 4 is 3 pi over 12. So start with 3 pi over 12. Well, I'm going to need to add to get to 11. What do I have to add to this to get to 11? 8. And now we find out, well, I already knew that the 3 pi over 12 was pi over 4. What does 8 pi over 12 reduce to? Well, they both divide by 4, 2 pi over 3. And sure enough, every time you start with any pi over 4 family, when you reduce the other one, it will always end up being a pi over 6 or pi over 3 that works. And so now we have, this is our alpha, this is our beta. It's a cos alpha plus beta formula. So we go to our formula sheet. The cos alpha plus beta formula is cos alpha cos beta minus sine alpha sine beta. That's root 2 over 2. Cos, quadrant 2 will be negative 1/2 minus sine is root 2 over 2 quadrant 1. Sine in quadrant 2 is positive. And so we get that cos of 11 pi over 12 is equal to negative root 2 minus root 6 all over 4. Then cos 4 times cos of 11 pi over 12 will be 4 times this. And your 4's will simplify. And you'll just get negative root 2 minus root 6. So that 4 out in front just meant that you had to times your final answer by 4. but the rest of it is the same as any other pi over 12 question. So section 7.5 that we finished, it introduced us to our sum and difference formulas. And with our sum and difference formulas, you have to be able to recognize when you have them. In particular, you're looking for when you have the right-hand side. It's like an identity. You can change it to the left-hand side to make it simpler. So we've seen some questions with solving, we've seen some questions with simplifying, and we've seen some proofs that use these formulas. We also introduced two kinds of questions that I gave special names. Example 1 in 7.5 was our double triangle question. The alpha plus beta formulas, sometimes you get a question where you have to draw an alpha triangle and a beta triangle. They're very much like our triangle questions in the past. And so we had that as a new type of question, our double triangle questions. And now we've also added the second main type of question from this section, which are the pi over 12 questions. So we can find the exact value of any pi over 12 one that we want. Again, I don't know if you wrote it down at the beginning. Till the end of class, you can work on number 7 or keep working on the questions from before.